Hi, in this video we will learn how to compute the determinant of an n by n matrix. So far we have learned how to do it for 2 by 2 and 3 by 3 matrices. In general, for n by n matrix, let A be an n by n matrix. So for these guys, the determinant and of A is given by, so as before we denoted by det of A. What we do is this. So we put the entries of the first row here and then continue up to A1n. You multiply each entry by the corresponding cofactor. So you multiply A11 by 1 cofactor. Add it to A12, multiply to 1 2 cofactor. And continue this thing. A1n, you multiply A1n by 1n cofactor of A. Well, you remember that when we have a cofactor, the sign -1 to the power I plus j, it always gives us, starting with the first entry, top left entry plus, so this will be A11. Well, determinant of A11, that's another way of writing this thing. Remember, cofactor has -1 to the power I plus j times determinant of A11. That -1 to the power 1 plus 1 is plus. Then minus, the second thing will be minus A12 determinant of A12. Next one will be plus A13 determinant of A13. Then minus, this alternates, and the last one, well, it will be -1 to the power I plus 1 plus n, A1n determinant of A1n. So this is the formula, and while the formula we use for 2 by 2 is also of this form. Remark, well, when you have determinant of a 2 by 2 matrix, let me write it this way, you see that what we have been using was a special case of this guy. So here, so first the entries of the first row, then 1 cofactor plus 1 2 cofactor. What is cofactor? Cofactor is -1 to the power 1 plus 1, or let me start with plus minus, so let me just ignore this -1 thing. So this will be plus, then determinant of 1 submatrix. So you delete row 1, you delete row 1 and column 1. The remaining will be just A22. Yes, minus, this minus comes from here, A12 determinant of A12. So here we have 1 row 1, delete row 1 and delete column 2. This will be A21. And well, you know that determinant of 1 by 1 matrix is that number there. So it will be A11 A22 minus A12 A21. This is the formula we have been using. Diagonal entries multiply, minus of diagonal entries you multiply. Okay, and also for the 3 by 3 matrix, I did this in one of the videos, that the way we find the determinant of 3 by 3 matrix, A11, A12, A1, 3, A21, A22, A23, A31, 32, 33. This is, well, A11 times 1 cofactor, so this will be plus determinant of, you delete row 1, column 1, you get A22, A23, A32, A33. So that's the first thing, plus A12 times, this guy is plus, this is minus. Now you delete the first row and second column. This will be minus determinant of A21, A23, A31, A33. And then the last one is A13 plus determinant of, so here you delete row 1 and column 3. So this will give us A21, A22, A31, A32. And you see, this is the formula we have been using, but now we have the formula for computing a determinant of matrices of higher order. For example, we can now find the determinant of this 4 by 4 matrix. 1, 0, 2, -1, 0, 1, 2, 3, -1, 2, -1, 0, 0, 2, 0, 1. Okay, so what do we do? Remember the formula. So we go one by one on the entries of the first row. 1, 0, 2, and -1. So let me put it like that. Then we multiply this guy by determinant, well, with the subfactor 1, 1. So this is subfactor 1, 1 has sign plus, this is minus, this is plus, this is minus. So this will be plus a determinant of, now 1, 1 submatrix. 1, 1 submatrix is a 3 by 3 matrix. You see, if I delete row 1 and column 1, I get 1, 2, 3, 2, -1, 0, 2, 0, 1. Then the second one, we have to delete row 1 and column 1. And here, the sign -1 to the power 1 plus 2 is going to give us negative sign. So determinant of 0, 2, 3, -1, -1, 3, the remaining entries, yes, this guy. How about this other one? Okay, here I have to delete this one, and this gives us plus determinant of 0, 1, 3, -1, 2, 0, 0, 2, 1. And the last entry is when you delete the first row and the fourth column, and that will give us, first of all, the sign there is negative, determinant of the 3 by 3 matrix, 0, 1, 2, -1, 2, -1, and 0, 2, 0. Okay, so we have to find all these determinants. The formula we have above does not give you the determinant right away. It turns the determinant into determinants of smaller matrices. Okay, so now we have to find the determinant of these 3 by 3 matrices. So determinant of, what is determinant of 1, 2, 3, 2, -1, 0, 2, 0, 1? this guy, we know the formula for this, so we do 1 determinant of negative 1 0 0 1 minus 2, let me write it here, 2 determinant of 2 0 2 1, and then plus 3 determinant of 2 negative 1 2 0. This guy now gives us 1 times negative 1 minus 2 times 2 minus 0 plus 3 times 0 minus negative 2, which is plus 2. And this is negative 1 minus 4 negative 5 plus 6, which is 1. Okay, so we have, now let's go back, this guy here is 1, so we have 1 times 1 plus this determinant. I need to compute this determinant. Well, at the end, whatever that number is going to be multiplied by 0, yes? So then the result is 0. So I don't need to compute that determinant. It is in the formula, but since it's going to be multiplied by 0, I don't need to compute it. Plus 2 times determinant of 0 1 3 negative 1 2 0 and 0 2 1. What is this guy? So here again you do the computation for this guy. 0 determinant of 2 0 2 1 minus 1 determinant of negative 1 0 0 1 plus 3 times determinant of negative 1 2 0 2. So 0 times anything comes up here is 0 minus, this is negative 1 times negative 1, this is plus negative 2 minus 0 times 3 is negative 6. This will give us negative 5 here. So negative 5. Then we have the second term here, this guy here, negative 5. There is a negative sign there, so together it will be plus 1. We need to compute the determinant of 0 1 2 negative 1 2 negative 1 0 2 0. I give you this one as an exercise. Try to find the determinant of that guy. This determinant is negative 4. And that will give us the whole determinant of the 4 by 4 matrix. Now we have 1 plus 0 minus 10 minus 4, which gives us negative 13. So determinant of this 4 by 4 matrix, now we computed that. This is equal to negative 13. And as you can see, well, this formula just reduces the determinant of n by n matrix to determinant of n minus 1 by n minus 1 matrices, and you have to compute. And right away after dimension 3, you see that it is a very expensive, computationally expensive operation to find determinant.